So this example 3 on page 57, we're finding the first and the second derivative of this composition of functions. So we're going to have to use the chain rule. So let's start with the first derivative. Bring down this exponent of 6 to the front, but keep everything inside exactly the same. Exponent goes down to 5. So half of the chain rule is done, but now we have to multiply this by the derivative of the inside part. That will be 2x. Now, let's simplify this by multiplying this 6 and 2x. So the first derivative equals 12x times x squared plus 2 raised to the 5th power. So we got the first derivative. Now I'm going to have to take the derivative of this to find the second derivative. And what I'm seeing is that this is a product. Okay, this is a product of 12x. You can factor out the 12, but I'll just deal with 12. You know what? I think I will factor out this 12. I'll find the derivative of x. Okay, I'll find the derivative of this and do product rule. Okay, so remember, product rule goes like this. You have to do first times the derivative of the second plus second times the derivative of the first. Here what I'm saying is I'll call my f to be x. I usually do 12x, but I'm afraid that like if I use 12x, I may have to I may end up with like big numbers, you know? So I'll try to just factor out this 12 and deal with this, okay? If I call f to be my x, that first piece of multiplication, then f prime is 1. G is that green, x squared plus 2 to the 5th power. Let us find the derivative of this using chain rule. Bring down that 5, but keep everything else the same with the exponent of 4. And we multiply this by the derivative of the inside part, which is 2x. So if I multiply this 5 and 2x, g prime becomes 10x times x squared plus 2 raised to the 4th power. So I got my 4 pieces for this product rule. Let me do the product rule now. So the second derivative is, let's start with the rule. First times, before I do that, guys, remember I pulled out this 12 in the front, right? So I'll draw a parenthesis and I'll put the 12 outside, okay? Now jumping into that product rule, first times, so that will be x, right? The derivative of the second, what is that one? Where is g prime? Right here. So I'll write that orange now, which is 10x times x squared plus 2 to the 4th. Now moving on to the second term of this product rule, plus, what's g? Let's see, g is this green right there. So I'll say x squared plus 2 to the 5th power. And finally, we're multiplying this by f prime. And f prime is just 1, so I don't have to put 1 there. All right, let's see if we can simplify this. I mean, because we got the product rule. We got the derivative here, but we're going to try to see if we can simplify this any further, okay? I'm going to factor something out. Notice that this has a common factor, okay? The common factor is x squared plus 2, and the greatest common factor would be that raised to the 4th power, right? So that's what I'm factoring out from these two terms, okay? So what's left inside the parenthesis? The first term still has x and 10x, right? If you multiply that, you get 10x squared, okay? Now moving on, plus, now what's left over here in the second term? If I factor out this binomial raised to the 4th power out, I still have 1 left, right? Because 5 minus 4 is 1. So I'll write down x squared plus 2. And let's see if we can simplify anything else in this red and blue parenthesis, okay? So keeping everything the same, the 12 the same, this x squared plus 2 to the 4th power the same, but I can combine this and say 11x squared plus 2, and that will be the perfectly factored second derivative of this function right here, okay?